All right, thank you guys for coming to the presentation about Hedgehog, instant offline payments, where we're going to learn about an alternative to the way that Lightning does payment channels with something that I made. So here we go. What is Hedgehog? Hedgehog is a protocol for a two-party payment channel, similar to Lightning channels. Got a multi-sig, you put some money in it, you do some stuff off-chain, yada yada yada, Alice pays Bob. That's the basic design. Hedgehog channels are pretty similar to Lightning channels. Actually, as I learned after making them, they're almost identical. And a lot of things that I thought were unique to them, you can do with Lightning too. But there are a few comparative benefits, so I'd like to talk about those. And let's do it. So what are Hedgehog benefits? Originally this was 2 slides, but I combined them into one because it was just one of them was text and the other one was kind of pictures. And this is more like pictures. So in the Lightning Network, this is how state updates happen. Just have it. It does, but you can't really see it. So in Lightning Network, state updates happen like this. They're a 4-stage process. Let's suppose the channel starts out and Alpha's having, 10,000 sats inside the channel. And she decides she wants to pay Bob, 5,000 of those sats. She's going to do something called a proposal. She's going to say, hey, here's a new state of the channel where there's 50% for me, 50% for you. And then she's going to wait for Bob to come online and maybe accept that channel or be like, no, I don't like it. And then we're done. Or then once he accepts it, then her wallet will show, okay, the payment has been settled. Bob has co-signed the transaction, and we're in a new state. So that is the 4-stage procedure of making a state update in a Lightning channel. In Hedgehog, the main difference is that it's a 2-stage process. In stage 1, same thing. Alice has 10,000 sats in the channel. It all belongs to her. But instead of having to propose a state and wait for Bob to revoke the previous state, she revokes the previous state and just sends him the new data. She says, all right, I'm creating a new transaction, I'm signing it, where I've got 50% and you've got 50%. I'm revoking the previous state, here's my revocation key, and now all Bob has to do is co-sign it if he wants to accept that state. But the nice thing about this is, first of all, it's simpler than the way Lightning does it. And second of all, Bob doesn't have to be online. Alice can do everything on her own. If she wants to do a state update, she can do everything she needs to do, send it over to Bob, and then she can go offline. She can consider it done. Which is really neat, because it's so much simpler, and it allows offline payments, which are, for me, the biggest headache with Lightning, is that when I want to receive money, I've got to be online. And if I've got an unstable connection, or if I'm don't run a node or something, that makes it really hard. Hedgehog fixes this. So, the major difference is who revokes and when. In Lightning, the sender waits until the recipient revokes the old state, and until then, their wallet shows a pending payment. I don't know if this has ever happened to you, but if you've ever been using Lightning, and you pay someone, and it kind of sits there and waits, and you get a little spinner, and you're like, hey, this thing is supposed to be instant, it's taking forever. That can happen in Lightning. It doesn't happen in Hedgehog, because the sender says, all right, I'm revoking the old state, can't use it anymore, and then their wallet immediately shows a settled payment, which is great. They don't have to wait for the other guy to get online. They can just send him the data and say, okay, that's the new state. How does it work? Well, just like with Lightning, the sats in a Hedgehog channel start out in a 2 of 2 multisig. Bitcoin address that's controlled by 2 parties. Anything that happens in that address has to be co-signed by both parties. In order to make a state update in Hedgehog, we have 2 transactions, which I call TX0 and TX1. TX0 puts all of the money in the address into something called a revocable multisig. Revocable multisig, well, it's really hard to show you how script works in English language. This is kind of an intermediate language that hopefully is somewhat readable. There are 2 script paths in a Hedgehog transaction. Script path 1, or a Hedgehog address rather. Script path 1 says that Alice and Bob are able to spend the money after 2 weeks go by. We use relative time locks for the 2-week time lock. And then the other alternative is that Bob can spend the money if he learns a secret that Alice currently knows. And this is sometimes called a revocation secret, because Alice is going to give this to Bob later, which she wants to revoke TX0. After the money goes into there, and after 2 weeks go by, there's another transaction signed by both Alice and Bob, using the first script path up there, that distributes 100% of the money to Alice and 0% to Bob. So there's an animated version of this. Money is in a 2 of 2 multisig, 10,000 sats are right there. TX0, it's already signed by Alice and Bob. sends the money from this address to this one. So 10,000 sats are in this address now, and then TX1 sends the money from here to Alice, but it has to wait 2 weeks. And that is a standard. State 1 in Hedgehog. If you want to move to state 2 in Hedgehog, where like she wants to send Bob some money, the stats are still in the original 2 of 2 multisig. Going back to that previous slide, the stats are still in here. Like she has not broadcast TX0 or TX1. She just has them. They're signed transactions that she's keeping in her wallet, but she hasn't broadcast them to Bitcoin yet. And consequently, the money's still in this address. So if she wants to send money to Bob, all she does is she makes a new transaction 0 that puts the money in a new replicable multisig, and this one's the same as the last one, except now Bob can revoke it instead of Alice. She sends Bob her revocation key, which is Alice's secret from the previous thing, and that makes it so that she can no longer spend the original TX0, because if she did, Bob would immediately be able to sweep that money. This is the revocation script that Lightning invented. We use it in Hedgehog too, because they're almost the same thing. But yeah, right here, Alice sends the secret instead of waiting for Bob to revoke it, Alice revokes it. The new transaction 1 distributes 50% to Alice and 50% to Bob. So in animated terms, the money's still in the original 2 of 2 multisig, but she has a new signed transaction that she sends over to Bob, and if Bob co-signs it, it will put the money in this address, all 10,000 sats, and then transaction 1, which she also signed, Alice also signed this, takes the money from here and distributes it 50-50 to Alice and Bob. And so now we're in state 2. The money's still in here, still in this address, but Bob now has these 2 signed transactions. If he wants to close out in this new state, he can do so, and he knows that Alice cannot go back to this state, because if she tries to, he can take the money from this address. She revoked it, and he has the revocation key. So then let's say we want to go to state 3 from here. Basically, Bob does the same thing again. He just puts all the money in a new replicable multisig. Once again, Alice is able to revoke this one. And let's say he wants to send her 25% of the money. He just has an address that makes it so Alice can revoke it, and then distributes it 75, 25, there. What you should be seeing is this is a loop. Alice and Bob can keep doing this forever. They never actually need to go to chain with this, because the money's always just sitting right here. But at any time, either party has what they need to settle the transaction and leave the channel unilaterally. So this is similar to Lightning in that you have a unilateral exit. It's a layer 2 of Bitcoin. But yeah, the really neat thing is Alice and Bob don't need to be online at the same time. Alice can send Bob money, or Bob can send Alice money when their counterparty is offline. And then the sender can go offline and the recipient can come online later and receive it. Which is great. So what about routing? How do we do routing in this thing? Well, I haven't implemented routing. I have implemented what I just showed you. But I want to base it on Matt Corallo's specification to come up with a way to do asynchronous payments on the Lightning Network. And I can use the same thing with Hedgehog, because once again, they're almost the same thing. But in his specification, if you want to make a asynchronous payment, you would create an HTLC in that third, in TX1. You would attach that HTLC to TX1, and then basically what I do, this is a modification of Matt's spec, is I have Alice create the HTLC, and then she actually sends the to Carol, whoever she's paying, she sends him, or her, the private key and the pre-image to that HTLC. And that allows the recipient to, whenever they get online, they can go to the routing node and say, hey, I will give you the pre-image to this HTLC that lets you take the money if you will pay a Lightning invoice. And that's what I show right here. So if you're going to do a routed payment, you attach an HTLC to TX1. And so in our previous state, Alice had 7,500 sats, Bob had 2,500. Alice wants to pay Carol, so she takes 2,500 sats out of her own address there and puts it in this HTLC. All of this happens off chain. And the HTLC script says Carol can spend the money after 1 day. This is using relative time locks again, check sequence verify. Or Bob can spend the money if he learns a pre-image. How does Bob get that pre-image? Well, Carol shows him a Lightning invoice that's locked with the same payment hash. If he pays that Lightning invoice, he gets the pre-image, and then he can settle this HTLC, thus increasing his balance to 5,000. So that works. You can do routing this way, and Hedgehog can piggyback off of the network effects that Lightning has. So I haven't implemented that, but I have implemented The rest of this stuff, like all this part, that's actually implemented, it's on my GitHub. And that's Hedgehog. It's simpler than Lightning, and the really nice benefit of it is that just like Lightning, payments are off-chain, but the recipient can be offline. And that works whether you are doing a routed payment, you can route payments to people even when they're offline, and you can also do it if you have a direct channel with them. So that's pretty cool. You can check it out on my GitHub, and if you want to, I can do a demo. You guys want me to do a demo?
Yes.
Yeah. Can I use you guys' laptop?